Hi, good evening. I've just been doing a bit of machining, and I've actually got back onto the finishing off the versatile dividing adapter that that I'm making so that I can screw the Taig chucks with a 3/4 16 thread onto the George Thomas's versatile dividing head, and I've just set it up in the lathe, and this is the spindle that is going to go inside the actual adapter, and it's going to be located in a recess, as you'll have seen maybe on my previous videos on this particular subject. And what I've done is I've just put a countersink in the end, so that I can place this screw and lock the whole thing in to the adapter itself. In fact, I've got it here somewhere. Yeah, here's the adapter that goes into the George Thomas dividing head. That taper there locates onto a hardened insert that goes on automatic bar feed machines, and so I made up this adapter to suit that particular insert, which is hardened and ground, so it's very accurate. So this unit here is going to go inside this recess inside there, and then this screw is going to go through and lock it in, so that the idea being is that it will always be removable. And this is the face here on the adapter that is going to go and locate on the back face of the Taig chucks. Okay, and the part that's sticking out of this part here, which is sticking out, is the register, the plain register that is going to fit in the back of the chuck. So hopefully that's going to give me what's the word, constant accuracy of putting the chuck on and taking it off, putting it back on again. That register in there, I'm hoping, is going to give the accuracy to the chuck, and the thread is only there to lock the thing on, to hold the chuck on. So that's what I'm actually doing. I thought that I would show you this setup. Because I thought it would be an opportunity to give you, again, if you haven't seen my other videos, to give you an idea of how this top slide, or compound slide, North American explanation, how this locks on. It was originally the Taig unit, but I've replaced the bottom part of the Taig unit and the the clamping arrangement, I got rid of that and made up my own base. And the locking mechanism is identical to the Hardinge hlv lathes, and it works really good. What I did was I set this compound over at 30 degrees, I think, or 40 degrees, I think it was 40 degrees, and I machined the, let's see, I machined the angle to suit the flathead screw, and I wanted to do that for accuracy rather than just coming from the tailstock. So I set the my top slide over and used that to machine the countersink. If I can find the Allen, as usual I can't find anything. I had it here here we go. Okay, this is the system the Hardinge locking system. Yes. Here we go, I'll show you. This is the locking system. The same idea as the Hardinge. There's an eccentric bolt that comes in through here and fits and goes through a hole in a floating plug, you could say, and it only takes a small movement of the eccentric to lock it on solid. So, and it slides backwards and forwards, so you can position it in any position, and then just by moving the Allen key about maybe 5 minutes on the dial of a clock, it's lock solid. It actually pulls the base down onto the cross slide. So I thought I'd just do a little short video just to give you an idea of how well it works. The trouble is that I can't see what I'm doing. Okay, this unit here I added on because the base was so thick. I made it an eighth of an inch thicker. Then I wasn't able to clamp tool bits on the top here and still keep my center height of the tool bit. So what I did was I added this unit here onto it, and it works very well. It's adjustable. There's a let's see, there's a Allen little set screw in here that allows the tool to go up and down on a dovetail, and you just lock it up like that, and that's it solid. So you can adjust the height for any kind of tool that you put in there. That's the unit, and it's take that out. Here you go, there's the unit. You can see that, and there, so you can see the dovetail underneath, I believe. There's the dovetail down there, That's attached to the top of the top slide, and this is the pin that drops out. It's just an eccentric pin, and this is the little plug with the hole in, and that's where that hole there is where the eccentric goes through, and it moves it up and down. And so that's how it works. It's very simple. And I don't know if I can get it in or not. There you go, it's in. So now when you just turn the eccentric, it pulls. This is in the groove, so it can't go any further. The only way it can lock up is for this to go down, and that's what the eccentric does, just there. So that's my adaptation of the top slide, and it's a much better system than the original Taig. So I'll leave that at that. This goes in there, and I'll take, where are we? I can take this out now. My little pads. So here we go. That goes into that recess. And then this screw, I hope I'm deep enough. I can always cut the screw down. There you go, and that's the spindle. And then it screws onto there, and there you go. So I have to make another one of these up now. I screwed up. This was the original thread that was on this adapter, and that's for a Drummond M-type, Myford M-type, a 3.5-inch lathe. And so without thinking, I cut that off on the hacksaw and adapted this when I should have left this alone, and made up a new adapter. So mistakes are made. It's too bad, but there you go. But that's going to be my next project, probably making up a new one of these and doing the same kind of thing, but instead of this I'll have this. I'll face that off the back and then bore a recess for that to fit, and then I'll be back and be able to use my F3 collets. I think they're Hardinge F3, I think that's what they're called. I've got a set. So there you go. It's almost done. I've got to check it, make sure that everything's running true in the dividing head, and if everything's okay, then I'll start making up a new one of these. Okay, I'm going to call off. Thanks for watching.